Dear students, I am Dr. Rajeev Sapre. This is the lecture number 41 about topology of metric spaces. Actually, we are working on concept of open set, closed sets, limit point, interior point, closure of the set, interior of the set, and corresponding results. So this part is very important because it is actually where we are studying metric topology. After this, we are going to study basically sequences, their convergence, Cauchy sequence, and many things. Actually, we will be working on complete metric spaces. After that, we may go for compact metric spaces, then connected and disconnected metric spaces, etc. But actually, whenever you say topology, it is a study of open sets. Right. So in this particular chapter, all these say 40 lectures that we have studied, in that most of the times we have worked with these concepts of open sets, closed sets, interior points and limit points, etc. So in that regard, we will do one more theorem and then we will go for another concept called boundary points. So the theorem that we are going to work on, or result we will say, it is something like this. Let x comma d be metric space and A be the subset of x. Correct? Then we have to prove that first part in that we have to prove x minus a closure. याचाच अर्थ काय? Complement of a च closure, right? That is nothing but complement of a closure of that, and we have to prove that it is equal to x minus interior of a. This is one result, and second result that we will like to prove is this, that if you take say x minus a, right, and its complement, then we have to prove it is equal to x minus a bar. This is equal to x minus a bar. This is what we have to prove, these two results. Can we see that these are very simple? We can verify. It is a good practice to verify all these results by taking simple examples, and when you are convinced, then you can try for proving. Okay, so now suppose you take R comma D as your metric space. That means whatever x they are talking about, we are taking it as R, right? This is R, right? So I will write it properly. Okay. Now you take A as, suppose subset ना, आपल्याला काय पाहिजे? A is subset of x, so we take A as closed interval AB. So if this is your R and this is suppose A and B, then this is your set. Closed interval AB means you know what is closed interval AB. It contains A less than or equal to x, less than or equal to B, all such real numbers. I'm just writing in short. Actually it should be in curly brackets, x belonging to R such that, etc. I'm not writing. You must understand closed interval AB whenever I'm writing, and all this is a subset of R. So all these are elements of R, real numbers lying between A and B, inclusive of A and B. That is your set. Now what is x minus a? What is complement of that? Its complement, you know, this is if you have A is closed interval AB. Okay, its complement is what? It is minus infinity to A open union B to infinity. Because you can see closed interval AB मध्ये नसलेली R मधली elements म्हणजेच A चं complement, because A I am taking as closed interval AB. So obviously it is minus infinity to A open interval union B to infinity. Okay, now what? Now we have to consider its complement. आता आपल्याला माहिती आहे कुठलाही ओपन इंटरवल घेतलं की त्याचं कॉम्प्लिमेंट क्लोज्ड इंटरवल असतं. सॉरी, कॉम्प्लिमेंट नव्हे, आय एम टॉकिंग अबाउट क्लोजर. क्लोजर इज द क्लोज्ड इंटरवल. सो हियर ए कॉम्प्लिमेंट, त्याचं बार जेव्हा मी घेणार क्लोजर, इट विल बी व्हॉट? मायनस इन्फिनिटी टू ए क्लोज्ड ॲट ए युनियन क्लोज्ड ॲट बी ओपन ॲट इन्फिनिटी. Right, this will be a bar, a complement bar. And what is x minus a interior? As a is closed interval ab, you know its interior, a interior is open interval ab, correct? And when you subtract it from a, म्हणजेच a interior चा आपण काय घेतलं? कॉम्प्लिमेंट. What will be that? A interior च complement म्हणजे open interval. A interior is open interval AB. Its complement when I take x minus A interior, it will be what? I have to remove all the points which are in open interval AB from R. So it will be definitely minus infinity to A, right? Union closed interval closed at B open at infinity. So this thing and this thing being same, we are actually verified that result. This is not the proof always, remember. Similarly, when you take x minus a complement, दुसऱ्या पार्ट मध्ये तुम्हाला म्हणजे हा म्हणजे असं म्हणता येईल आपल्याला की रिझल्ट 1 इज व्हेरीफाईड. रिझल्ट 1 व्हेरीफाईड. आता काय होईल बघा? x minus a. Now your a is what? Closed interval ab. So what is x minus a? म्हणजेच ए चं कॉम्प्लिमेंट. ए चं कॉम्प्लिमेंट म्हणजे काय बघा? हेच आपण लिहिलं इथे, मायनस इन्फिनिटी टू ए युनियन बी टू इन्फिनिटी. सो युअर लेफ्ट हँड साइड इज दिस, दॅट इज ए कॉम्प्लिमेंट. एक्स मायनस ए त्याचं कॉम्प्लिमेंट. इज इट राईट? वॉट एव्हर आय एम वी आर सेइंग, अदरवाइज दिस रिझल्ट मे बी समथिंग डिफरंट. So it is not complement actually. X minus a itself is a complement. So it is x minus a interior. Sorry, extremely sorry. This is x minus a interior and it is equal to x minus a bar. We have to prove. मग आता इंटिरियर काय होणार? जर हे तुमचं कॅपिटल ए असेल ए बी, तर ए इंटिरियर म्हणजे आधी एक्स मायनस ए काय होणार आहे? तो एक्स मायनस ए आपण इथे लिहिलेला आहे. एक्स मायनस ए ह्याचाच अर्थ काय? ए कॉम्प्लिमेंट दॅट वी हॅव रिटन. आता ह्याचा इंटिरियर काय होणार? म्हणजे इथे जर आपण म्हटलं ना की एक्स मायनस ए इज वॉट? एक्स मायनस ए इज वॉट? मायनस इन्फिनिटी टू ए ओपन युनियन ओपन बी टू इन्फिनिटी. आणि मग ह्याचं इंटिरियर, आता हा स्वतःच ओपन सेट आहे. हे दोन ओपन सेट्सचं युनियन आहे. सो आर्बिट्ररी युनियन ऑफ ओपन सेट्स बिंग ओपन, दिस इज ओपन. त्यामुळे कुठलाही सेट ओपन असला की तो आणि त्याचा इंटिरियर हे सेम असतं. त्यामुळे एक्स मायनस एचा इंटिरियर काय होणार? हाच सेट, मायनस इन्फिनिटी टू ए युनियन बी टू इन्फिनिटी. त्यामुळे ही जी लेफ्ट हँड साईड आहे आली एक्स मायनस ए बार. आता ए जर माझा क्लोज्ड इंटरवल ए बी असेल तर सॉरी, तर त्याचा तो स्वतःच क्लोज सेट आहे. आणि वी नो वेन सेट इज क्लोज इट इज इक्वल टू इट्स क्लोजर. त्यामुळे इथे ए जे क्लोज्ड इंटरवल ए बी आहे तर तिथे मला लगेच लिहिता येईल ना. आय विल इरेज धिस पार्ट. राईट, व्हॉट आय कॅन राईट हिअर? ए बार इज इक्वल टू, ए जर क्लोज्ड इंटरवल ए बी असेल तर ए बार पण क्लोज्ड इंटरवल ए बी असणार. आणि मग एक्स मायनस ए बार म्हणजे ह्याचं कॉम्प्लिमेंट. सो एक्स मायनस ए बार विल बी दिस सेम थिंग, मायनस इन्फिनिटी टू ए म्हणजेच काय ॲक्च्युअली आहे? एक्स मायनस क्लोज्ड इंटरवल ए बी. अँड एक्स मायनस क्लोज्ड इंटरवल ए बी इज वॉट? मायनस इन्फिनिटी टू ए ओपन युनियन ओपन बी टू इन्फिनिटी. सो दॅट इज व्हेरीफाईड. x minus a interior is x minus a bar. This is verified by this result. This is not a proof, but always we should verify by taking some simple examples. Generally R you can take as a metric space with usual distance. and take some closed interval or open interval as your subset A of R, and verify what are the things that we will actually like to prove. Okay, so this can be the good habit. This will help you to understand actually what we are saying. And then it is not necessarily R always. You can take any known metric space and work this for that. Okay, so now we will try to proof. Right, proof is what? So we have to show that. So to prove that A bar complement is equal to x minus A interior. हे दोन सेट्स आहेत ॲक्च्युअली, आणि तुम्हाला प्रूव्ह करायचं आहे की हा सेट आणि हा सेट इक्वल आहे. आता आपणाला काय माहिती आहे बघा, वी ऑलवेज नो दॅट द स्मॉलेस्ट क्लोज्ड सेट कंटेनिंग ए कॉम्प्लिमेंट. आता ए कॉम्प्लिमेंटचा बार आहे ना, हे बघा इथे काय म्हटलोय आपण, इट इज always see important to understand what we are actually saying. A complement चा bar, what it will be actually, what is A complement bar? A bar complement आणि A complement चा bar ह्या दोन वेगवेगळ्या गोष्टी आहेत ना. हे इथे x मायनस ए आहे ना, म्हणजे हे ए कॉम्प्लिमेंट बार असं आपणाला ते खरं नीट लिहिलं पाहिजे. इथे पण तसं ते लिहिलं पाहिजे. आय एम बाय एरर, आय एम बाय मिस्टेक, आय हॅव रिटन समथिंग डिफरंट. सो व्हॉट ॲक्च्युअली आय हॅव टू प्रूव्ह इज ए कॉम्प्लिमेंट क्लोजर is equal to x minus A interior. This is what I have to prove. Correct? Now what we know is this, that A complement is an we will show that, म्हणजे हे जर मला इक्वल आहे असं प्रूव्ह करायचं असेल तर मला काय प्रूव्ह करावं लागेल, वी विल शो दॅट द स्मॉलेस्ट क्लोज्ड सेट कंटेनिंग ए कॉम्प्लिमेंट. कारण ए कॉम्प्लिमेंट बार, ए बार म्हणजे काय असतं, इट इज द स्मॉलेस्ट क्लोज्ड सेट कंटेनिंग ए. बघा आपण असं म्हटलंय ना मागे, ए बार इज स्मॉलेस्ट क्लोज्ड सेट, स्मॉलेस्ट क्लोज्ड सेट containing A. So same logic we can apply here. मला A complement bar म्हणजे हे सिद्ध करायचं आहे. So we will prove that smallest closed set, smallest closed set, smallest closed set containing A complement, containing A complement is x minus A interior. If I prove this, we are through. Okay, so now what we know, see, we know that okay, so smallest closed set containing A complement is x minus A interior. हे आपणाला प्रूव्ह करायचं आहे. Okay, now we know that A interior is open set, right? This is obvious. Every set when you take its interior is an open set, and also we know that A interior, this is A interior is subset of A. A interior is subset of A. So that implies x minus A, x minus A, right, is subset of x minus A interior. Correct? X minus A is subset of x minus A interior. Right? That implies, but what is x minus A? It is A complement. So A complement is subset of x minus A interior. Right? Say this is our result 1. X minus A or A complement is subset of x minus A interior. This is result 1. Now see, A interior is open. A interior is open set. This is very obvious. So that implies what it implies, x minus A interior is closed set. Right? So what we have proved, x minus a interior, that implies x minus a interior is a closed set containing a complement. Now आपल्याला प्रूव्ह काय करायचं आहे की तो x मायनस ए इंटिरियर जो आहे तो स्मॉलेस्ट आहे असं प्रूव्ह करायचं. स्मॉलेस्ट क्लोज सेट कंटेनिंग ए कॉम्प्लिमेंट, त्यातला आपण x मायनस ए इंटिरियर हा क्लोज सेट कंटेनिंग ए कॉम्प्लिमेंट हे प्रूव्ह केलं. पण आता मला काय प्रूव्ह करावं लागेल, आणखी कुठलाही जर क्लोज सेट असेल m किंवा p कुठलाही, राईट, जो ए कॉम्प्लिमेंटला कंटेन करतो, तर x मायनस ए इंटिरियर हा त्याचा सबसेट असेल असं मला प्रूव्ह करता आलं पाहिजे. सो आय विल राईट इट हिअर. लेट m be any closed set, m be any closed set, m be any closed set containing a complement, right? That implies a complement is subset of m. A complement is subset of m, and that implies x minus a complement. A complement is subset of m, right? Containing a complement, no. So a complement is subset of m. So that implies if you take complements, that means what? A complement ची complement म्हणजे a होईल, a will be containing x minus m. A will be containing x minus m, and that implies x minus m, right, is subset of a. X minus m is subset of a. Now m is closed set. M is closed set, right? So that implies x minus m is open set. X minus m is open set. X minus m is open set. How it is open set? Contained in m. Contained in capital M. Sorry. आपल्याला काय म्हणायचं आहे? x minus m is open set contained in A. Sorry, not capital M. Contained in A. Sorry, this is error. Contained in A. This is obvious ना, x minus m is subset of say contained in A. पण आपल्याला माहिती आहे की ओपन सेटचे जे आपण रिझल्ट्स प्रूव्ह केले त्याच्यामध्ये आपल्याला असं माहिती आहे की ए इंटिरियर इज द लार्जेस्ट ओपन सेट कंटेंड इन ए, राईट. सो इथे म्हणतो मी आता, बट ए इंटिरियर इज लार्जेस्ट ओपन सेट contained in A. So x minus m must be subset of A interior, कारण A interior हा लार्जेस्ट असतो आणि x minus m हा पण एक ओपन सेट आहे जो A मध्ये आहे. पण आपल्याला माहिती आहे की A इंटिरियर हा लार्जेस्ट ओपन सेट असतो A मध्ये, कंटेंड इन A. सो x minus m must be subset of A interior. Now when you say x minus m is subset of A interior, it means what? I will erase, I think this is now done, so I will erase this part, right? This part we will erase. Now when you say x minus m is subset of A interior, it means what? M contains, मी आपण दोन्ही बाजूची कॉम्प्लिमेंट्स घेऊया. M contains x minus A interior, right? That implies x minus A interior is subset of M. म्हणजेच काय प्रूव्ह केलं आपण, हे समजा मी 2 म्हटलं तर मगाचा जो फर्स्ट रिझल्ट आणि सेकंड रिझल्ट, यू कॅन गो बॅक अँड विजिट दॅट पार्ट ऑफ द लेक्चर. वी कॅन सी दॅट आता आपण M हा कुठलाही एक क्लोज सबसेट घेतला होता, राईट. सो now what it implies is x minus A interior हा जो सेट आहे तो कसा आहे, आपण जे सुरुवातीला म्हटलं होतं की we will try to prove that smallest closed set containing a containing a complement is x minus a interior. So that is proved here, right? So from 1 and 2, now we can declare from 1 and 2. What is proved? We have proved that a complement bar is equal to x minus a interior. This is proved. This is x minus a interior. ह्याचाच अर्थ काय? It is complement of a interior. So you can say a complement interior is complement of a interior. A complement's a closure. Closure of a complement is equal to complement of a interior. So such results, they are not difficult. What we used here is this, that smallest closed set containing the given set is the closure. That part we have used. Also in between the proof we have used a interior is the largest open set contained in A. With the help of these two results about closed sets and open sets, we have proved this result. Okay, so now we will continue to prove the second part. Second part we will try to work now. तिथे आपल्याला काय प्रूव्ह करायचं आहे बघा. I will erase all these things so that we can have a clean slate. What I have to prove now? We have to prove x minus a interior. X minus a interior is x minus a bar, right? So we know first. So second part we are now to prove that x minus a interior is equal to x minus a bar. Okay, we know that a bar is a closed set, right? So, and also we know that a is subset of a bar. So we know that a bar is closed set. Closure is closed set. We have proved all these results. So, and also we know that A is subset of A bar. A is subset of A bar. So that implies x minus A will contain x minus A bar. Right? This implies x minus A bar is an open set, is an open set. कारण काय a bar हा क्लोज सेट आहे. कुठेतरी लिहू आपण पाहिजे तर as a bar is closed, x minus a bar is open and it is contained in x minus a. So x minus a bar is an open set contained in x minus a. आपण इथे लिहूया as a bar is closed, x minus a bar is open. So now this is meaningful statement. X minus a bar is an open set contained in x minus a. Okay, say this is result 1. Now what we will say, let G be any other open set. Let G be any other open set contained in x minus a. Contained in x minus a. Right? What does that imply? G is subset of x minus a. Right? But now see, so x minus g, if I take, what does that imply? X minus g म्हणजेच काय, g चं कॉम्प्लिमेंट. मग हे इकडे सुपरसेट होईल. सुपरसेट ऑफ x minus a चं कॉम्प्लिमेंट म्हणजेच a. राइट? दिस implies x minus g. Now what is that? G is any other open set. So x minus g is a closed set. So x minus g is closed set, right? Containing a. Right? But what we know, a bar is the smallest closed set, but a bar is smallest closed set. A bar is smallest closed set containing A. A bar is smallest closed set containing A. So that implies A bar is a subset of X minus G. That implies X minus A bar contains G, right? But that implies G is subset of X minus A bar. So now this is suppose 2. इथे तुम्ही काय म्हटलात, X minus A bar is an open set contained in X minus A, आणि इथे तुम्ही म्हणताय G हा जो दुसरा कुठलाही ओपन सेट घेतला, it is also subset of X minus A bar. So what does it mean? X minus A bar is the largest open set. दुसरा कुठलाही ओपन सेट घेतला तरी तो ओपन सेट X minus A bar ह्या ओपन सेटचा सबसेट आहे. So what does it mean? X minus A bar is the largest open set containing A. म्हणजेच काय झालं, right? So X minus A bar is the largest open set contained in X minus A. So I will write it here. X minus A bar is largest open set right, contained in X minus A. That is X minus A interior, कारण largest open set contained in A म्हणजेच A interior will be equal to X minus A bar. So that is proved. So I hope you understood. Lot of previous results we are using in proving this result. So we have to have a clear understanding of all the previous results about open set, closed sets, closure of the set, interior of the set. Then also we should know that when A is subset of B, A complement contains B complement. All such techniques we are using in proving this result. So I hope you understood this. We will continue in the next lecture. Thank you.